All right, with that being said, let's take a look at your topics for this week. You have two sections for reading this week, derivatives of functions and differentiation rules. I kind of think of this as the long way and the short way. So section 3.2, just go ahead and read that. You do not have any textbook homework problems assigned in that section because you guys have already practiced the long way in section 3.1. So we're going to move on to section 3.3 and let you guys start learning the differentiation rules and applying those, because that is really the bulk of what your AP exam is going to be. Now let's take a look at what I mean by differentiation rules, or what I think of as the shortcuts. Last week we focused on the long way to find a derivative. For the next few weeks, we're going to be focusing on the fast way to find derivatives. All right, so we have differentiation rules here. I very strongly recommend that you use Quizlet or note cards and put these down, because these are rules that you're going to need to know. First of all, the derivative of a constant is always 0. Then you have the power rule. So, variable raised to an exponent, well, the exponent becomes the constant, and then you subtract 1 from the exponent. Then there's the constant multiple rule. If you have a constant times x, the derivative would just be a constant. And if you have the derivative of a constant times something else, it would be that constant times the derivative of your item. Then there's the sum rule, which says if you're taking the derivative of the sum of two functions, you could take the derivative of each function and then add them together. The product rule gets a little trickier. It's not like the sum rule. You can't just multiply the two derivatives together. For the derivative of two functions, f of x and g of x, being multiplied together, you take the derivative of the first function and multiply it by the second function. Then you take the derivative of the second function and multiply it by the first function, and you add them together. So again, that's a bit different than the sum rule. Last, we have the quotient rule, and this is the one I'm going to focus on today because this one is a bit trickier. This one has a bit of a longer formula to it, which I'm going to write at the top up here for us before we practice using it. To find the derivative of the quotient of two functions, f of x, g of x, I'll tell you the trick that my calculus teacher helped me use. He always said bottoms up and then proceed. And then don't forget your bottom squared. And what he meant by that was you start with the function on the bottom and you multiply it by the derivative of the function on top. Then you take the derivative of the function on the bottom and multiply it by the function on the top. And he used the word proceed because it reminds him of the product rule. It's very similar, there's just the minus sign. And then you square the bottom function, not the derivative of the bottom function, but the bottom function itself. So let's look at this example. Here we have a function y equals 5x plus 2 over 6x minus 1. I'm going to name the top function f of x and the bottom function g of x. So we're going to start by taking the derivative of the top function. This looks like using the sum rule. So we're going to take the derivative of 5x and the derivative of 2 and add them together. According to the constant multiple rule, the derivative of 5x is 5. And we already talked about the derivative of a constant being 0. So the derivative of 5x plus 2 is just 5. Now onto the bottom. We're taking the derivative of 6x minus 1, which again is using the sum rule. Taking the derivative of 6x and the derivative of negative 1 and adding them together. Again, using the constant multiple rule, the derivative of 6x is 6, and then the derivative of negative 1 goes to 0. So now let's plug this into the formula. We bring up that bottom function, 6x minus 1, multiply it by the derivative of f of x, which is 5. Then we subtract the derivative of our bottom function, which is 6, times our top function, which is 5x plus 2. And now we expound the bottom, 36x squared minus 12x plus 1. And from here, I'm sure you guys are comfortable with simplifying the algebra, continuing to use the distributive property and simplifying the top. The bottom isn't really going to change at this point. (30x minus 30x), those will cancel. We're left with negative 17 over 36x squared plus 12 minus 12x plus 1. And that would be the derivative of our original function. One more topic I would really like to cover today is the idea of higher order derivatives. The derivative that we practiced today was the first derivative, meaning we only took the derivative one time. If that derivative we find is differentiable, meaning that we can take its derivative, the new derivative would be called the second derivative. This process can be continued to a third, fourth, fifth, all the way out to however many derivatives, as long as each derivative is differentiable. I also wanted to go over the notation for this. For the first function, we say f prime of x, and we have one apostrophe mark there. For the second derivative, we say f double prime of x. From there, we'll continue to say third derivative, fourth derivative, however many derivatives. But we use one apostrophe or tick mark there to represent each time we've taken the derivative, which is why you see one apostrophe at the top. Second has two, so on and so forth. Have a blessed week.